Hello all. In this video we discuss about the some example related about the block diagram reduction method. This is very important for the GATE and the NET examination for electronics and communication. So first of all, determine the transfer function C by R from the block diagram shown in this figure. Now this is one signal, this is plus minus, this is input signal R, and this signal then multiply by gain G1, and there is another comparator plus minus, and from here connected one gain G2, and here another gain is known as G3. These two output are again connected to the summing point. This summing point, this is H1. Okay, this is a feedback, and this feedback is coming from this output of this amplifier. This is our C, and this is one takeoff point, and here one feedback is coming from the final output. Okay, so now these are block diagram. So what we will do that? So first of all, we shift the takeoff point after the block G2. So now first we shift this takeoff point before this block. This is after this block, and now we convert this before this block. So for the solution, we draw the circuit again, block diagram again. This is G1, this plus minus, this is the signal R, this is all plus, this is minus, this is again G2, and this is again G3, and here these two signal, one is plus, another is plus, and here the feedback is present coming from the output. And now we convert this. First of all, now what we'll do that this takeoff point is basically coming from this, from here. Now we're shifting this from here to here. Now what is the modification of this block? This block is G2 into H1. Okay, because the takeoff point is shifting from here to here. So this is our first modification of this in this block diagram. Okay, please note down. This is our first step 1. Now in the step 2, we see that again we draw this circuit G1. Now for these two block we can apply the parallel rule. We know that. Yes, right, absolutely correct. We apply G1 plus G2. Yes, right. This is the output C, and here plus and minus, and this is output, and there is one feedback is coming present. There is G2 H1, and these output are coming from here. Okay, so now what will do that? Now we're shifting this takeoff point from here to here. Now if we're shifting this, why we shifting this? Because if we're shifting this point here to here, then we apply here one unity feedback, and also the total closed loop feedback theorem is applied here. So now again this signal R, now shifting this point. Okay, now this is G1, this is plus minus, this is G1 plus G2. The feedback is present from here. Now shifting this point, okay, from here to here. You see, now what is again G2 H1. Now this is takeoff point is before this block. Now after this block, yes, right, this is basically G2 plus G3. I'm sorry, this is basically G2 plus G3. Yeah, right. So now we divide this by G3 plus G2. Why? Because this takeoff point is basically before this block. So now after this block, this is basically multiply by this. So to avoid this G3 plus G2 gain, so we can divide this signal G2 into H1 by divide by G3 plus G2, because when this is multiply this, so this is the original signal G2 into H1, so that's why we divide here G3 plus G2. Okay, so now they see that there is a unity feedback here and this is a total out closed loop feedback here. So now first we reduction this block. Okay, so now what is our formula? So now this is an G1. Okay, so now this is basically our one block. Why? Because this is unity feedback, so this is a G and H equal to 1 here. So now what is the formula? Yes, right, G2 plus G3, 1 plus GS into HS, that means 1 plus G2 into G3 only. H is equal to 1 here. Yes, right, very good. Yes, so now here and here, now here the main block, the feedback block, is known as G2 into H1 plus G3 plus G2. So now consider for the simple, to reduce the complexity of this mathematics, we consider this is the gain H dash S and this is consider G2 dash S. So now what is the block diagram look like? The block diagram look like this is G1 G2 dash, because these are the series rule, you already know that, and this is a block diagram of HS, means the feedback system. Now here positive and negative, these R and these are C. So now last one, what is the feedback? What is one unity gain feedback? Yes, right, this is G1 G2 dash plus 1 plus G1 G2 dash into H dash. Now putting this value from here, G2 dash and H dash and G2 dash, so now we get our proper, yes, right, transfer function, because CS by RS we already know that the Laplace transform of the output response by Laplace transform of the input response include all initial condition equal to 0. Okay, so this is very important. So now we discuss another example. Okay, okay, now for the second example, this is an input signal R, this is the gain G1, this is again G2, and here coming the two signal plus and plus, because they are in the same phase. Student, one thing should be noted, that it is your homework that any analog circuit concept, from any analog circuit, you should be replaced this block diagram by the circuit, otherwise you cannot analyze the circuit or synthesize the circuit or the proper circuit designing for the specific application in the industrial sector or engineering sector. Okay, this is very important to design any inverter or to design any communication circuit or any receiver and transmitter or any filter circuit, or which is applicable for analog signal processing and both the digital signal processing. But in a digital signal processing, this control system is not used there. Is used instead of Laplace transform, we use the jet transform. In the later video we will discuss about that. So first of all, in this problem, so there are three gains are available, and these are the summing points. So our first objective is shift this summing point. I again repeat that, shift the summing point before the block G1, that means this before the block G1, to a position after the block G1. So what will do that? So first of all, G1 is then first coming, then G2 is here, this is a signal R. Okay, then these two signal, this summing point is shifting here to here, so that's why we here. So now this is a plus and plus, there is no change in this block G3, but one thing should be remembered. What is the change of this block? Because this block is connected through this summing point which is before the block. Now this is after the block. Okay, so now when this is going to this block and again further to coming this output, then this signal is multiplied by G1. So that's why here H1 into G1. So H1 is multiplied with G1. Okay, so this is very important. Okay, now this is the first step. Now second step is that interchange the consecutive summing point. That means these two are interchanged. This is very easy. So this is very easy. This step is very easy, because just we first consider here, we just interchange this here, this summing point here and this summing point here. So now this is 2 plus, is plus minus. Okay, these are G3. Yes, right, very good. This is H1 into G1. This is C, this is R. Okay, now what is the equivalent of this block? Yes, student, please. Yeah, right. Yeah, very good. This is basically parallel rule. Yes, right. Very good. Thank you. So now, what is the block? Yes, right. G3 divided by 1 plus G3 into H1 into G. Yes, very good. So this is an output C. Because here we apply the unity feedback for this block. Here we apply the unity feedback concept. Okay, and this is the negative feedback. Now this is the, what will do that? Yes, right. This is basically, yes, right. This is basically the series rule. Yes, yes, right. This is basically we apply here the series rule, and the get output C by R, because these two signals are G1 plus G2, and from here we apply the unity feedback system. So here we apply the unity feedback system, and for unity feedback system the equivalent block is look like that: G3 GS divided by 1 plus GS into HS. Okay, that's right. So now these two blocks are in cascade operation. Okay, these are the series rules basically. Okay, so C by R means this into this. This is very simple. Okay, okay, now our next problem is this input signal R. Now this is an feedback signal coming from here. This is H1. Okay, this is connected to G1 block, and the overall there is one feedback is present here, H2. This is coming from the output. This is in block G2. This is output C. These are minus minus. Okay, so now here the block diagram is look like that. G6, this is G4, and this output is coming from here, and this is G3. Okay, now this block is connected to here. This is positive, this is positive, this is positive, and this is G5. Yes, right. Now this is again G5. Okay, now solve this problem. So this is a very complex, you see that, but it is very easy. First of all, in the right hand side, we solve this in the right hand side, we see that this basically this G3 and G4 are basically coming from the output, but these two signal are just in the parallel rule. So therefore we addition of these two signal. Okay, this is our first task. So what we'll do that now in the second picture. Now this is a solution. Okay, for the solution this is R, this plus minus. Here we present the signal H2 feedback signal. In the negative there is a G1. Okay, there is a block G2. This feedback is coming from the output C. Now here one G5 gain is present coming from here, and from here one feedback H1 is present. Then there is a summing point, and here one signal is coming, addition plus, and here one gain G6, and these two signal are just in a parallel rule. That's why addition of G3 plus G4, and here G5. Okay, so now this is our second step. These are after the first step. This is our, and this signal is plus, and this signal also plus. Okay, so after the first step, this block diagram is reduced from here to here. So just see that we first replace this block in a parallel rule. Okay, G3 plus G4. So this is very easy. Now in the second step, what we'll do that we shifting this takeoff point from here to here. Student, please note down, otherwise you cannot recognize the appropriate point where we modification of these blocks from the point. So now shifting of this, so shifting of this block from here to takeoff point from here to here, so it is basically divided by G2, because after this is multiplied by G2. So to reduce the gain G2, we multiplied by G5 by G2. Okay, so now what is the third block? Now in the third block, first here one feedback H2, here the gain G1, this is the gain G2, this is a C, this is R, this is positive, this is negative, this is negative. Okay, then next this is H1, yes, right. Then there is another summing point. This block is now represented by G5 by G2, and taking the summing takeoff point is coming from here, and this is a plus, this is again plus, this is basically G6, and this is G3 plus G4. Okay, coming from this point. Okay, so this is very easy. Now see that here we again see that these blocks and these two blocks are in again parallel rule, because both signal are coming from the same point and from the output signal. Yes, right. And these two are in, yes, right, very good, that is in the cascade rule on this, or in the series rule. Yes, absolutely right. So after this we can draw this diagram. This is an H2, this is output C, this is positive, this is negative, this is G1, G2, sorry, this is not in this direction, I am extremely sorry, just a minute, because this is a forward loop, extremely sorry. Now this is the direction. Okay, now fix this. Now what is the value here? This is H1 block, and this block is G5 by G2 plus, yes, G6, G3 plus G4, yes, right, and coming from here. Okay, so after this we get this expression. So this is very easy. Now this gain is multiply this feedback gain. Is just for the simplicity we consider this 2 gain multiply after this 2 parameter. Say consider this is an alpha. Okay, just consider the alpha, because to simplify the mathematical, because these terms are very large, there are lots of parameters included here. So now this is a plus, this is a minus, this is R, this is a feedback signal H2 coming from the output C, this is a forward path G1, G2 connected from here, and here one block is known as alpha. In this alpha, this expression is this. Alpha is basically this into this, as we mentioned earlier. Now what will do that? Now our task is to separate this summing point in the one summing point to two summing point. Now what will do that? these are plus R. Now again here we extra addition of this. These are G1, G2. These output a C. There is one feedback is present known as H2. This minus is plus. So now what is in this feedback? This feedback is basically alpha here. Now first we solve this unity feedback. Okay, so after this unity feedback, the G into H. So now what is the main block here? Yes, GS, right, 1 plus GS into, yes, very good, GS into HS, yes, right. Now this is feedback alpha. Now again we here apply the feedback rule. Now for the simple mathematical calculation, we consider this is beta. Okay, just for the consider for now what is the CYR? CYR is GS, that is beta divided by 1 plus GS into HS, alpha beta. So now putting the value of beta and alpha, we get the appropriate value of this output response by input response using this block diagram method.